はい、おはようございます。国会読中の人です。今日はですね、僕のトロント大学の、最終日ですね。一応まだ試験とか普通にあるんですけど、普通の授業がある日は今日が最終日というところで、ちょっと今遅れ気味なんですけど、ちょっとこれからプレゼンテーション、グループのプレゼンテーションをしなきゃいけない、授業にちょっと向かっていて、でその後僕は卒論のプレゼンが今日入っていて、そのプレゼンをするために今セントジョージキャンパスっていう、トロントの中心のキャンパスにいるんですけど、そこからちょっと1時間半くらい離れたスカボロキャンパスっていうところに行って、そのプレゼンをしなきゃいけなくて、僕のスーパーバイザーがそこの先生なので、だからちょっと今日はちょっとバタバタお整理してますけど、ちょっと忙しい一日になりそうです。頑張っていきます。The recommendation would be using convolutional layers, convolutional filters. So in this paper, they are expressing user-item interaction as aということで、プレゼンテーション自体はよくできたかなと、思います。ちょっと俺が遅れてたせいでだいぶギリギリになっちゃって、もうなんか僕のグループメンバーが登壇してる時にもうなんか僕が入るみたいなということで、これからトロント大の別キャンパスのスカボロキャンパスに、向かっていきます。ちょっと図書館に行って作業しようと思ったんですけど、よくよく考えたらこのキャンパスに来るのもおそらくこれが最後になるんで、散策しようかなというところで、なんでしょうね。だから今4月の頭なんですけど、4月の下旬まで一応、試験があって、でその後は6月の中旬に卒業式があるんで、1ヶ月くらいは本当に何もしない無職なんですけど、で僕は8月から仕事が始まるんで、これが東京であるんですけど、合計何年間5年間か働いてる期間も含めれば5年間過ごした、カナダともう本当にあと2ヶ月でおさらばというところで、なんだろう、僕あんまここに住むこと自体はあんま好きじゃないですけど、離れるってなるとちょっと寂しくなりますね。難しいっすね。すごい自然公園みたいな感じで、しかもなんか自然公園なんだけど全部バリアフリーっていうだからこれずっとこういうなんかスロープが続いてて、なんか障害者の方とかにもすごく優しい自然公園ですね。さすがカナダなんつうの、エンクルーシブネスなんだ、日本語なんだ、とりあえずそうインクルーシビティの国ですね。川が流れてますよ。なんかあれですね、ビーチバレーのコートみたいなのがありますね。一応なんかスタンドみたいなのがありますね。カバディコートなわけないカバディコートじゃないけど、なんか Google マップ上で見たらなんか コミュニティガーデンっていうのがあったんで、なんかなと思って来てみたら、なんかあれですね、なんか育ててますね誰が育ててるのか、もしかしたらここのね学生がそれぞれなんか育てていい農場みたいなのを与えられてるのか、なんか説明がありますね。A living laboratory for students, faculty, and staff and neighbors. These columns work on this. だからまあそうですね。学生とか、まあ教授とか、あとまあこの近くに住んでる人とかが自由に栽培していいよみたいな趣旨の、ガーデンみたいですね。いやー、空き時間に野菜育てる大学生活っていうのも悪くないかもしれないですねそういうことね、さっきの川で空き時間に魚釣ってサッカーして、野菜育てる、そんな学生生活があってもいいんじゃないでしょうかね。いいな、いいとこだな。のどかですごく静かで、もうなんか精神衛生にもすごくいい気がする。
Are you gonna record it?
Yeah, okay. Just write it down.
So introduction, Dr. Cochran. And yeah, so I'm Ken. Today I would like to talk to you about my thesis project, which is titled Kokai Dog, an NLM-driven framework for scaling parliamentary representatives. Kokai means diet, the Japanese parliament, so just and dog is just from Google Doc vibes. So just to motivate this research, let's just start off with this little exercise. I want you to think of a representative from your electoral district. Do you first of all know who they are? Do you know their political position on the topic of defense, for example? On a scale of 1 to 100, how likely are they to support an increase in defense budget? Now, because I'm talking to a room of political scientists, you guys might have been able to answer these questions confidently. Maybe not, but the reality is that most people in society are not. And this is a huge problem in current day democracy, where people don't really know what they're voting for and what kind of positions they're voting for. So that really motivates this research, where we want to quantify political positions of parliamentary representatives in a scalable and reliable manner. So pictorially speaking, we are thinking of having all these representatives and putting them on this single axis spectrum for these different questions, like, okay, should our country use nuclear power? Should we increase the defense budget? Should we increase the VAT? And so on. Now, political scientists have done a lot of research in this area. For example, Bu and Rosenthal, back in 1985, they looked at roll call votes, and they developed an algorithm called nominate algorithm, which essentially looks at the roll call votes and then puts them in Euclidean space. And they were very successful in doing so. Now, Dr. Cochran here, he has worked on work in 2020, where he has trained a shallow neural network, which is trained on a task to predict a word given surrounding words, and also being fed in the indicator variable, which indicates from which party that speech came from. Now, in the process of training that neural network, the network also learns to embed the indicator variable in a meaningful manner. Now he has applied PCA, principal component analysis, which is essentially dimensionality reduction, on that embedding to put the parties in Euclidean space, and he was able to infer these different axes as well. Now last year, Dr. Cochran and I, we worked on this paper, which was using LLM embeddings, and essentially we would create these reference points that represented two polar opposites for a particular topic, and then we would project everyone else onto that axis to express all the representatives' ideologies or positions as a scalar value in regards to that topic. And this is still very relevant for this current research, as fundamentally we are still using this algorithm or this framework to scale the representatives. Now let's talk about the data we've used. We've used the Japanese parliamentary speech data, which is made available by the Japanese government. They have an API for this. Now we would first create a bunch of query words in regards to different topics, like for example in regards to defense, it might be the Japanese Self-Defense Force, JSDF, defense, security, etc. Now we would use these query words to query the API. We would get raw sentences or speeches from the API, and then we would use our fine-tuned BERT classifier, which is trained on hand-labeled dataset of about like 1,400 data points. Now this classifier would then classify only the opinion-based sentences, and then we would embed them and store them. So essentially, what we're doing is we are taking this huge chunk of speech data, and we are looking, and because using all of this speech data would be very heavy and very noisy, so what we want to do is we only want to extract the opinion-based sentence from these speeches. Now talking about the scale of data we've collected data on the current representatives and councillors as well as historical representatives. And yeah, these are the numbers. Essentially, we did a fair bit of collection of data. Now our method involves a multi-step process where we first take these collected speech data and summarize them using a large language model like GPT-4. The purpose of this is to get rid of any noise that is induced by any tone or particular context. So like we want to essentially normalize the kind of language we are using. And we would take these position summaries generated by our large language model and throw it back to a large language model, telling it to extract axes of controversies. So for example, these groups of summaries would be speeches related to the topic of defense, for example, and the LLM would be able to extract, okay, in the topic of defense, acknowledging the JSDF in the Constitution might be one axis, increasing or decreasing the defense budget might also be another axis. And finally, well, not finally, and then we project. So essentially, this is straight from our past research where we have these reference sentences. So we would generate sentences that represent both extremes of a particular axis. We would embed them, and we would create an axis that represents that spectrum for that particular topic. And then we would project everyone else onto that axis so that we have a scalar measurement for how pro or con they are in regards to particular political ideas. Now, we also wanted to do some diachronic analysis. So what we did was we would collect these party speeches, well, opinion-based party speeches for each year, and then we would embed them, and we would again project them using the previous approach. Now, let's talk about the results. So this is particularly for the topic of acknowledging the JSDF in the Japanese Constitution. So a bit of context, the Japanese Self-Defense Force has a fair bit of equipment right now. But however, in our constitution, it is stated that we cannot have any form of military. So, and this constitution was written right after the Second World War, under the supervision of the US. So we see that it is no longer really aligned with the current reality of Japan, where we have a fair bit of investment and equipment in our army or self-defense force. But our constitution still denies the existence of it. So we see that the left-leaning parties, for example, the Japanese Communist Party in red, or the Constitutional Democratic Party in orange, they are more positions on the left side, meaning they are against the acknowledgement of the JSDF in the constitution. And more conservative parties, like the LDP in black, or the Komeito in light blue, they are more positions on the left side, on the right side, meaning they are pro-acknowledgement. Now, the right figure indicates, shows a U-map plot, meaning I essentially reduce the dimensionality of these embeddings so that it's more visually understandable. And the black line indicates the axis on which we are projecting everyone. Now, I did the same thing for the topic of whether we should restart our nuclear power plants or not. Again, this is a huge controversy, especially after the Fukushima nuclear disaster in 2011. So again, we see that the more liberal parties such as the Japanese Communist Party and the Constitutional Democratic Party, they are more on the against side. And the more conservative parties like the LDP and Komeito, they are more on the right side. Now, it's great that we have all these measurements, but we still have to verify that these measurements are actually valid and aligned with expert predictions. So however, unlike the US political science field, where we have scalar measurements for each parliamentary representative through like the use of nominate scores, like the first related work I've shown you, Japan does not have that. Partially because our field of political science is not as developed in the computational sense. So we don't have these kind of sophisticated measurements. So what I did was I looked at this NPO, Mielka, who are essentially an NPO aiming to make Japanese politics more transparent. And what they do is they consult a group of experts to put these parties on a single axis scale in regards to different political ideas. So what we can do is we can use these ordering of these parties and compare them to the ordering obtained by our methodology to evaluate how good or bad our methodology is. Now, this is our result when evaluating our methodology. So for the topic of JSDF and acknowledgement in the Constitution, we see that the ordering of the parties is well aligned with the ordering obtained by experts. Now, I'm showing you multiple metrics, which is essentially aiming to do the same thing, which is comparing, expressing how similar two distinct arrays are. Now, the reason I'm using different metrics is because they're slight technicality, but they're looking at slightly different things. And so this allows us to make a more rounded evaluation of how good our measurement is. So we see that our method is well aligned with the expert predictions, as well as outperforming our previous approach, where we did not summarize the speeches, as well as some technicalities in regards to generating the reference sentences. Now, let's look at some diachronic analysis. So these are three parties: the Liberal Democratic Party in black, Komeito in light blue, and the Japanese Communist Party in red. And this is essentially showing how pro or con they are in regards to the topic of defense. So the left figure indicating whether we should increase the defense budget or not, and the right figure indicating whether we should acknowledge the JSDF in our constitution or not. Now, we see that the conservative parties have mostly been pro increase in defense budget and also pro acknowledgement in JSDF, where Komeito is slightly more careful or slightly more hesitant to increase a defense budget, which is expected because although Komeito is a conservative party, they're also a religious party. So they are most of the times, in regards to defense and military, very careful in expressing their opinions. Now, these two parties have formed the conservative coalition in the Japanese government for the past, for a very long time now. And however, we should notice a weird trend here where there's a sharp dip in the how pro increase in defense budget the conservative parties are. Now, the way to explain this is that during this time, it was a liberal government and not the conservative government, meaning the conservative parties became more critical of the budgeting decisions made by the liberal government. And also another thing, we see around the Russian invasion of Ukraine, there's a sharp increase in the sentiment that we should increase our defense budget, which is understandable because Japan does neighbor a country like Russia. So what is happening in Ukraine is not really unrelated to the current geopolitical situation of Japan. Now let's do the same thing for whether we should use nuclear power plants. So the left figure indicating whether we should restart them, and the right figure indicating whether we should extend the operation period of current nuclear power plants. Now, this is also very interesting because before around 2010 to 2011, all the parties seem to have a very uniform view of nuclear power plants. There's not that much variance when looking at different parties. However,
after 2009, 2010, 2011, we see that the stance of the Japanese Communist Party becomes extremely anti-nuclear power plants. Now, why could this be? Again, comparing it to historical events, we see that this aligns roughly with the Great East Japan earthquake and the Fukushima nuclear disaster following it. So it is very interesting to see before this disaster or this time, there wasn't really that much difference in stances comparing the Japanese Communist Party and the Liberal Democratic Party. But currently, the Japanese Communist Party is known to be very anti-nuclear power plants. So, to conclude, we were able to develop a scalable and reliable framework for scaling parliamentary representatives using large language models. And we were able to show that our method also aligns with expert predictions. And we were able to explain certain trends by looking at historical events and link them back to our observation. So as a next step, we want to implement this findings on this website called Kokai Doc, which is a website run by me, which aims to make Japanese politics more transparent to the public by having these electoral district maps or these visualizations of how different politicians are located on a single spectrum. So by implementing this, we are hoping to educate Japanese voters more and to help them make more nuanced and more evidence-based decisions, voting decisions in the future. So yeah, thank you so much for listening. And yeah, any questions?
はい、ということで、卒論のプレゼンが終わりましたと。で、結果としてはそうですね、結構良かったんじゃないかと思います。自分がやってる研究の結果も結構良かったし、すごくインタープレタブル、の結果に理由付けがしっかりできてて、で、すごくそのデータがなんでそうなってるのかっていう理由付けみたいなのがしっかりできてて、良かったねっていうところで、全体的にはすごく褒めてもらいましたね。で、そのプレゼン終わって今はちょっと中華のこのキャンパスはあれなんですよね。メインのセントジョージキャンパスよりも学食が充実してて、なんでちょっと中華というかチャイニーズの、あれを、買いましたと。ちょっと辛いんですけどこれ。辛い。だけどこれで卒論は全部終わったので、卒論関連のものは全部終わったんで、残すところはもう試験の勉強して成績取ってっていうところでございます。はい。で今回のプレゼンテーションは一応全部録画してあるので、フルバージョンを、YouTube でも公開しようかなと思っています。今日はもう今日はとりあえず休もうかなって思っていて、もしくはちょっとたまった YouTube の編集ちょっとやんなきゃなっていうので、YouTube は完全に趣味なんで別に苦とかではないんですけど、こんな感じですね。だからこれからちょっとでも昼ご飯食べて、そうですね、せっかくこっち来たし、こっちの図書館でちょっと作業をして、で家に帰ろうかなと、思っております。はい、以上です。はい、昼飯も食べたので、もう家帰って明日から本当にもう期末勉強を始めなきゃいけないので、ちょっと今日だけはもう何もしないっていうのをちょっと目標にしたいと思います。なのでもう本当に家帰っても本当にすげえダラダラしようと思います。やっぱね、今しかできないよね、ダラダラということで、気が向いたら動画編集もします。ちょっと 帰っていきます。